In this video, we're going to talk about the Hindu-Arabic positional system, which is section 4.1 of your textbook. What is the Hindu-Arabic system? This is the numerical system that we use every day. The numbers 1, 2, 3, 4, 5 are all Hindu-Arabic symbols. The position of the digit determines its value. So if it's in the ones place, it's a ones value. If it's in the tens place, it's a tens value. So if a 5 So for example, the number 456, 4 is in the hundreds place, 5 is in the tens place, and the 6 is in the ones place, which is how we get 450 and 6 for that. Please note that this is a base 10 system. In this class, we're going to talk about the base 10 system as well as other bases. So here is a couple of decimal charts and a way to look at the the base 10 system. What do they mean by base 10? Each position correlates to a base 10 value. If we look at the table over here, we'll see that we have an exponential form, the value in its name. If 10 is raised to the 0 power, then the value of that becomes 1. 10 to the 0 power is 1. This is then the ones place. However, if the exponent changes to 1, in other words, we're in the second position, then we're going to get a value of 10. 10 to the first is 10. 10 squared becomes 100, 10 cubed is 1,000, and so on and so forth. The nice thing about base 10 is that we can go on to as many different places as we want, and there'll always be a value associated with it. The digit in its place gives its value. So let's practice expanding Hindu-Arabic numbers. We're going to expand it by using its place value or its position of each digit. Let's suppose that we have the number 5,248. If I want to expand this number, I'm going to use the position and the corresponding base 10 value to write the number. 8, for example, is in that the farthest right side place. So that's going to be my 10 to the 0 power. But now I need to add the 4, which is in the 10 to the first power spot. Then I'm going to add the 2, which is in the position of 10 squared. And then I'm going to add the 5 in the position of 10 cubed. I can also write this in descending order of the exponent, and I'll get the same number. But this 10 to the 0 represents the ones place. 10 to the first is the tens place. Oops, right here. 10 squared represents the hundreds place, and 10 cubed is the thousands place, which is why we have, ones, tens, hundreds, and thousands. Let's suppose we have 3,007. Well, we know that 3 is in the thousands place, so that's going to be 3 times 10. Thousands is going to be represented by 10 cubed. Now, 0 is in the place of the hundreds and the ones, or hundreds and tens. So we could write 0 times 10 to the second plus 0 times 10 to the first, but it's not necessary. So we could just go ahead and write plus 7 times 10 to the 0. Remember that 10 to the 0 power is 1. This represents 1,000. This represents 1. And that's it. That's all you have to do to expand. Remember, the place value and position of the digit will determine its value. The first spot way over here will always be to the 0 power, and then it increases as we move to the left. If you're ever unsure of what value to start at, you can always start with the ones place and go backwards like we did here. So if we can expand, we can also condense. If expansion, we write the number using the exponential form. Here, we're going to take the exponential form and we're going to condense it back into a singular number instead of an expression. But we do the same thing. This time we're going to calculate what we're given. So if we have 6 times 10 to the second plus 3 times 10 to the first plus 9 times 10 to the 0. Remember that each digit gives me the value and each power of 10 tells me the place. This tells me the hundreds place. This tells me tens, and this tells me ones. So this is going to be 639. Here, we have to pay attention to what the exponent is. Here, here, here. Notice that I have 10 to the 0, which is the ones place, but then I skip the tens place and go straight to the hundreds. I skip the thousands and go to the 10,000s. If we do have these spaces, then we have to make sure we use the placeholder 0 so that we don't change the value of the number. So here, you would get 8 in the 10,000s, 0 in the thousands, 9 in the hundreds, 0 in the tens, and 3 in the ones place. So we get 80,903. You could always expand this. You can always rewrite this, including the missing place values. So 8 times 10 to the 4th plus 0 times 10 cubed plus 9 times 10 squared plus 0 times 10 to the 1st plus 3 times 10 to the 0. And so then here, these values are represented by those digits. We want to be comfortable being able to expand and condense, because this is how we're going to be using these skills to convert between a base 10 system, such as the Hindu-Arabic system, to a different numbered base.